let's work on a problem with sigma notation. So sigma is, let me scroll down more space to give ourselves some definitions. All right, that is the capital Greek letter sigma, and it tells us in math to add repetitively. So if I say that I want to add xi, that I is the index, and it counts for me, it counts my x's. And I'm going to add from I is equal to 1 all the way to I is equal to n. So it starts at 1, right? So the first term in the sum is x1, right? This right here is this term when I is equal to 1. And now this sigma tells me to add the next term in the sum. So the next term in the sum would be x2, right? This right here is that term when I is equal to 2. And I keep doing this. I add x3, x4, all the way until xn, right? When I is equal to n. So that's the last term in the sum. So this is my definition of a sum. And all the sums that we're going to be dealing with in this class are going to be finite. So I'm only going to add a finite number of things. So up here in that squirrely circle is the definition of a sum. The sum of xi's from I is equal to 1 to n is exactly what that says. It's the sum of all the xi's if I starts at 1 and it finishes at n. Right? Really no more complicated than just repetitive addition. So let's work on a few problems. I have two data sets here. The first one I call x, and inside the data set x are a bunch of little x's, and I count those little x's with the index I. All right, so this point right here is x1. This is the second x value, so it's x2. This is x3. This is x4. All right, so if I specify that this set is a set of x values from 1 to n, then necessarily n is equal to 4 because I have 4 data points. In the same way, I have another data set here that I call y. The data set y is filled with a bunch of little y's that are counted with I from 1 to n. So this is y1, this is y2, y3, y4. So again, necessarily n is equal to 4. All right, let's solve some of these. So I have 4 problems listed here, and we'll move down the page to solve each one because the sum is repetitive addition. We're going to need a lot of space. So the first one tells me that I need to add up all of my xi's. So number 1, I need to sum all of my xi's. And I'll very often leave off the n and the 1 because you're always going to sum through all of your data. All right, so if I ever write down just the sigma without specifying that I starts at 1 and goes to n, it's assumed that it runs through the entire data set. Right, so this is x1 plus x2 plus x3 plus x4. And that is, where's my data? My x's are 4, 6, 8, and 10. So this will be 4 plus 6 plus 8 plus 10. What does that give me? That gives me 10. That gives me 18. So in total, I have 28. So the value of this sum is equal to 28. All right, let's do something a little bit more complicated. Let's work on, so we're done with number 1. Let's work on number 2. So here, I want to add up 2 times my y's. So I want to add 2 times my y's. So notice the order of operations here. I want to figure out what 2 times my y's are first, and then I want to add them up. So this will be 2 times y1 plus 2 times y2 plus 2 times y3 plus 2 times y4. And that spans my data, right? I only have 4 y values. So what are the y values? 1, 3, 5, and 7. So this will be 2 times 1 plus 2 times 3 plus 2 times 5 plus 2 times 7. All right, so I get a 2 plus a 6 plus a 10 plus a 14. That right there gives me 20. This gives me 12. In total, I've got 32. So the value of the sum of 2 times the y's is equal to 32. All right. Something a little bit more complicated. Let's work on 3 now. I want to sum the values of 3 times the square of my x values minus the y value. So I want to sum 3 times the square of each x minus the y value. Right, so again, notice the order of operations. Before I add anything, I need to figure out what I'm adding. I need to figure out each one of these guys for each one of my data. So this will be the first term in the sum is 3 times the first x value, which is 2 squared, minus the first y value, 1. Right, this right here is this expression when I is equal to 1. Right, when I is equal to 1, your x value is 4, your y value is 1. Oh, sorry. So your x value is 4, not 2. The first y value is 1, right? Yes, okay. All right, so that's the first term in the sum. Now the second term in the sum is now I is equal to 2. So it's still this expression, but now I is equal to 2. So it'll be 3 times 6 squared minus 3, right? This right here is that expression when I is equal to 2, right? And this sum right there is telling me to add those two. All right, so maybe the pattern is becoming clear. I'll add the next term in the sum, which is 3 times my third y value, because I'm in the third term of the sum. So I is equal to 3. My third x value is 8. I square it because I'm told to square it. I subtract off my third y value. My third y value is 5. And I kind of ran out of space right there. The last term in the sum is 3 times the fourth y value, sorry, the fourth x value squared, minus the fourth y value. All right, so again, notice that order of operations. You first figure out what you're adding, and then you add them all up. All right, so the first term in the sum, 4 squared is 16. 16 times 3, what is that? I get 48. 48 minus 1 is 47. Try to do this in different colors. I'll then add to that the next term in the sum. The next term in the sum, 6 squared is 36. 36 times 3 gives me 108. And if I subtract 3 from that, I get 105. All right, the next term in the sum is 8 squared, gives me 64. 64 times 3 is 192. I subtract 5 and I get 187. And finally, the last term in the sum, I is equal to 4 now. So I'm dealing with the fourth. This is here. 10 squared is 100. 3 times that gives me 300. Minus 7 gives me 293. All right, so to finish this, I've got 47 plus 105 plus 187 plus 293. That gives me 632. All right, what about this fourth sum? So the fourth sum tells me I need to add up all of my x's and then subtract off the sum of all of my y squareds. So I need to add all of my x's and subtract the sum of the y squared values. So again, the order of operation is important. You need to figure out what this is, and you need to figure out what this is, and then you need to perform the subtraction, right? Because this is an object, and you're subtracting from it this object. So let's figure out what those objects are first. So this will give us, what is the sum of the x's? That is 4 plus 6 plus 8 plus 10. All right, so that right there is the sum of my x's. I now subtract from it the sum of the y squareds. So my y's, what are those? Those are 1, 3, 5, and 7. So those would be 1 squared plus 3 squared plus 5 squared plus 7 squared. Right. This is the sum of the square of my y values. All right, so what do we get? 4 plus 6 plus 8 plus 10. In fact, I think the sum of the x's is just number 1. All right, we got 28 for that. This gives us a 28. I subtract the sum of the y squareds. So let's figure out the squares first. Let's do it slow. I've got 1 plus 9 plus 25 plus 49. That's going to give me 1 plus 9 gives me 10. If I add 25 to it and then a 49, I get an 84. And 28 minus 84 results in a minus 56. So it's a new notation, but it's really no more complicated than just repetitive addition.